So this is difference. For you, maybe you should understand how to construct empirical one f sub n. It's easy. We have the portions only, and so that we can have the accumulative probabilities. All right, so this is the second approach, using CDF difference. And next one, we want to have based on probability, but we try to choose a pair. The pair may be based on here. If we have a way to show, for example, CDF, then we can choose the pair based on probability. Oh, okay. So we have a 2-point pair based on probability and, probability here. Probability. So we have a pair and have another pair. So if based on probability, we call probability versus probability plot. Or maybe based on quantile. So given probability, the point here is quantile. So quantile, the same probability. Quantile and quantile, so QQ probability. So we can base on probability to determine a pair of probability versus probability, quantile versus quantile, so that we can have the plot. And the plot, actually, we should have a line with a slope of 1. This is the ideal one. So the ideal one should have a slope of 1 here. But normally, it won't be a case like that. So we may have a situation like this, or this, or maybe this. And this is a QQ plot. And here we have a PP plot. And even for QQ, PP, should we have the same one? No. But we try to check around. Actually, along the line of with the slope of 1, here it's okay, and this one maybe you have a concern. Oh, it seems to be not okay if we check the portion here, but finally we still accept that one. And here, if we have the demand size, it's okay. So summarize, we want to have that. In fact, I didn't know if we have the given probability, we can have a pair of quantiles. Or given a quantile, so it's a quantile, we can have the corresponding, given an observation, we can have the different probability because of the fitted one, or because of the empirical one. So we can have the concept to have the PP or QQ plot. So let me get back to this. How to have the PP or QQ? Previously, I didn't have the idea how to have a pair. First of all, here, this is a PP plot. To have the pair, actually, we can have the fitted one, right? The fitted one, we have observation, the ice observation. First one, second one. So here we have the sorted data. And sorted data put into there, and then we will have the probability. The probability, if we have the sorted data from the smallest one to the largest one, actually we have a pair from the smaller probability to the larger probability. So we have the sorted one. And the sorted one, actually this point and this point, they are not the same. but almost the same. So that says approximate the result. The result actually is portion. I over n. I over n, it should be the CDF we have. But finally, we have a correction. So this is a correction. Someone think, oh, okay, the proportion not so good. So we try to have a proportion. I minus a half. So this is a correction. Maybe you think, why we have the term of a correction? Because someone think we have an observation, but we don't have all the possible observation. So it doesn't mean the proportion should be the correct one. So we have minus a half to have minus a half to have so we have minus a half to have the possible correction. If you don't think so, that's okay. You just use I over n. But the current results actually we have we adopt the correction. So we have I minus a half over n. So if we want to have the PP plot, all right. So we want to have a PP plot. We can consider this. All right. And consider this, then we can have the pair. The pair actually, which one first? Fitting one first, or the empirical one first? It doesn't matter. All right. Here we choose empirical first, and then fitting one. All right. So this is a probability. So this one to have all pair shown on a figure. This is called the PP plot. All right. And QQ plot, theoretically, we should given any possible probability to find the pair of quantiles. But this time, because we have the current way to show the result, so we have the inverse function directly. Inverse function, so we have the observation. Inverse function. So same, follow the way, empirical first and then the fitting one. The fitting one, let us have the results. Oh, okay, it's a high sample. And this one based on the empirical one. So inverse function using the fitting one, inverse function based on this, so we can have the result. So we pass on the result to have the observation. And this one, then we call it's the QQ plot. So this one not the same as the original one I already have. Actually, we can have any probability. We try to have a pair of quantile and quantile from the empirical one, from the fitting one, right? So, and then we can have the result, but we don't pass on that one. We pass on the result if we can start from PP plot like this. We try to have the inverse function. An inverse function here, it's a quantile. And likewise, this is a quantile. But the first quantile coming from the fitting one, and the second quantile from the, the first quantile from the empirical one, but the second quantile from the fitting one. So we can have the two quantile from different sources to serve as a pair. And the plot all the pair, then we can have a QQ plot. All right. So let me mention this again. Normally, to have a probability, how to have the probability pair here. Right? So probability 1 and probability 2. So we have a pair. And the order here, we have the fitting one first. And then we have empirical one first, and then we have the fitting one. So this is a way to construct a pair if we want to have a probability. So how to have many probability? 1, 2, 3, 4, 5. we have n observation. So first observation, we have a probability 1, probability 2, probability 3 set of probability, and the nth probability. And if we want to have the quantile, actually we can have any probability. For example, first probability, second to nth probability. But we try to choose, okay, if we have observation 1, and based on the feeling 1, so it's probability 1. So based on probability 1 to have the corresponding quantile for the empirical 1. So we have the specific probability based on the feeling 1. So that's why we have the function like this. And so that it's easy to have the observation based on the concept like, oh, okay, we have the feeling 1. But actually, feeling 1 or empirical 1, maybe you have a bit confused because empirical 1 plus the feeling 1, right? But I don't know if we can choose any probability. Still, we can have the QQ plot. But we based on the formula here, so that's why we have the way to show the QQ pairs. All right, about the PP and QQ plot, the concept allow you to have 2 minutes to check.